Okay, the video that I'm going to do is called Operations with Radicals. So radicals are very much like many of the other things we have done. You have to have like terms before you can add them. So if I have 2 square root of 3 plus 5 square root of 3, we have 2 plus 5 is 7 square roots of 3. You see, this is 2 of these square root of 3 plus 5 more of these square root of 3, and I end up with 7 square root of 3. I can also do a subtraction the same way. And 2 minus 5 would be your negative 3, so this would be negative 3 square root of 3. So it's exactly the same as combining like terms because these are the same. What if we gave you 2 square root of 3 plus 5 square root of 2? Now what's wrong with this? Well, the square root of 3 and the square root of 2 are not like terms. Therefore, this is already simplified. The only thing you could do with this would be to plug it in a calculator and get an approximate answer, but it would not be an exact answer. So these are really important that you're able to simplify these radicals and then use them to add and subtract and even multiply and divide. We're not going to do all the operations today, but we are going to do some of them. So now let's look at things that are not so clear and obvious. What if we have the square root of 25 minus the square root of 36? Well, first of all, they are not like terms in this form, are they? Because the square root of 25 is a different square root than the square root of 36. So what are you going to do? Well, first of all, simplify this. Your 25 is 5 times 5. That's 2 of a kind, so the square root of 25 is 5. And many of you would know that already. The square root of 36, many of you know, is 6, but it's 6 times 6. There's your 2 of a kind. So now, these are like terms because they're both integers, and 5 minus 6 is equal to a negative 1. So as you see, by simplification, we can take radicals that are not the same and turn them into something that is the same, but they don't always simplify, but sometimes they do. So now let's look at something a little more complex. How about the square root of 32 minus the square root of 50? Now, again, neither of these are like terms, but let's simplify. 32 is 2 times 16. 16 breaks down into 4 times 4. There's my 2 of a kind, and this is the one that is not the same, so this is 4 square root of 2. Now let's do the same with 50. 2 times 25, your 25 breaks down to 5 times 5. So we have 5 comes out of the house. The square root of 2 is the 2 stays inside the house. And don't forget we're subtracting. Okay, now, are they like terms now? Yes, they are, because they both have square root of 2. So 4 minus 5 is going to give you a negative 1 square root of 2, which could also be written as negative square root of 2. So as you can see, we can simplify these by simplifying the original ones, and if they come out to be like terms, then we can add or subtract them, okay? So now let's look at ones, again, even more complex. Okay, how about this? 3 times the square root of 49 minus 2 times the square root of 32 plus 5 times the square root of 50 and minus 2 times the square root of 98. Okay, None of them are the same. None of them are like terms. So let's start with this one. This is 7 times 7. There's my 2 of a kind, so this will be 3 times 7, which is 21. So that's just an integer. Okay, so now let's look at this one. This is 2 times 16, and this is 4 times 4. So we have 2 times 4 times the square root of 2, because that comes out of the house. So we have minus 8 square root of 2. Okay? 50. How about 2 times 25? 5 times 5. That gives me 5 times 5 square root of 2, which is plus 25 square root of 2. And 98 is 2 times 49, 7 times 7. So this gives me 2 times 7 times the square root of 2. So I've got minus 14 square root of 2. Okay, so now let's see what we have. Well, first of all, 21 doesn't have any like term, so obviously 21 is going to be the first thing. Negative 8 square root of 2 plus 25 square root of 2 is going to leave you with 17 square root of 2 as a positive, and minus 14 square root of 2 is going to be plus 3 square root of 2. So as you can see, we can take some pretty complex things and we can simplify them all the way down to where we have an expression. But notice, there's no answer to this. There's an answer, but it's an expression that is in simplest form, and it's exact. So that's where you are with this. And it works really nicely to work it out and have your simplification of radicals in this way.